Well, hi, and thanks for coming and joining me in my shop here. Today is the 28th of July. It's been a few days since I've worked on this. I have another project I'm kind of switching on and off with. So this guy's back on my bench, a great big stereo amplifier. So I think the next step along the way here is to prove that these two output transformers are in good shape, or do not have serious damage. Let's put it that way. The reason for this is because of this output tube right here, which I've written in big bold print, short. So when I put this in my Stark 966 tube tester and I do the short test, when I get to switch number 3, position 3, bingo, a short on here. Now I haven't investigated what kind of short that is. It's short between cathode and heater, it could be short between cathode and plate, who knows? I don't know offhand. It's probably be between the heater and the cathode. That's a typical kind of failure problem here. So the problem with the shorted tube is we don't know what other damage it may have done. So this is the position it was in for sure. So you would think this would be the output transformer that may be popped, but we don't know the history of this thing. And for all I know, somebody swapped the, after having one channel go out, somebody swapped these tubes around and then damaged the other output transformer. Chance of these being damaged is low, by the way, but let's check it out. So we're going to first check out this one. Now let me just check the tube heights here. So if I flip this over, I think it's going to sit on top of these two tubes. So I'm going to pull these two out. They're long tubes. I'll flip this whole thing right over. Oh yeah. Well, that all looks easy. Thankfully there aren't a lot of parts in here. Yeah, just kidding. Okay, so which transformer was it? It's this one here. It's this tube socket here. So first thing I'm looking for are any resistors that are popped open. That would be a good thing. That would mean that the resistor failed instead of the transformer, but I don't see any such thing. I see wires that have been cut and resoldered like that, right there, going to this capacitor. Boy, you'd think if they went so far as to cut this, I guess as a testing thing maybe, I don't know why they would cut it, but they would replace this anyway, because they replaced that. They didn't do this one, but he cut it. So there's no outward indication of anything bad having happened, unless you think these replacements are the indication. Typically a shorted transformer is not going to do something to a capacitor. It's going to pop a resistor, or pop its own winding. Okay, so I'm going to have to test it with an ohm meter. Oh my gosh, look at these bundled up wires. They're all turned dark. It's pretty impossible to trace these really effectively. Look like they come down to here for some reason. Well, so obviously I got to get a look at the schematic and see if I can't sort out where to test to prove the secondary windings. Winding, maybe, is good on this. Let's take a look at the schematic and we'll see what we can see. Okay, so here's the manual for, I guess this doesn't look like a full-blown service manual, it's just no way long enough. Nice block diagram, you don't see too many of those. Parts list, schematic. This is the 2-pager, so this is the front half. Here's the back half here. 2 channels, one down here and one up there. Power supply shown in the middle. Let's go up here. Here's the output transformer. We can take a look at how this is done. Let's zoom in on it. Oh my my gosh. Okay, so what's happening here? So we see two outputs on this transformer. One is going to these remote speakers, so this would be the 70 volt or the high impedance system, I guess we can call it that. Then the regular low impedance 8 ohm or whatever they are speakers are hooked up in here. And this switch, I'm going to guess is the power level switch. It's ganged onto this one. Yeah, I'm going to guess that's what this is. This is the power level. And my thinking here is this switch is kind of setting the unit up to share power between this and this. Now this is normally driving a known set of speakers that are inside the cabinet. They are what they are when the machine is built, and that's it. What's varying is the amount of load you put out here with how many remote speakers you put on. So once you get, I don't know, 4 or 5 remote speakers, maybe you got a big restaurant here you're trying to feed power through, there isn't enough power for these guys if you let this one hear all the power coming from here. So you kind of deafen this one a little bit. Maybe you're snapping this switch this way. You're getting less and less windings driving the speaker. By the way, I'm just figuring this out as I talk. I'm telling myself this stuff and you're listening to me talk to myself about it. So that must be what's going on. So without any of this in use, perhaps the place for this switch is all the way here. That would, develop the highest output voltage and power going to the internal speakers and the least over here. That's probably how this should be set. Okay, figure that out, but that's nothing to do with I was going to say that has nothing to do with a shorted winding, but it's possible if this switch were set here, so the entire winding is energizing the speaker. You know what, you're not going to back up, Jim. What's going on? How are you not gonna blow the secondary side? What am I talking about? Okay, so if there's damage out here, it's because something stupid was done with speakers. Come on, Jim, wake up. Where's my coffee? Here it is. Okay, let me take a gulp of coffee here, and we'll start working on the primary side, which looks kind of complicated too. Okay, well, blessed be the hearts of the engineers who designed this. So here's the plate voltage coming in at 365 into here. That DC voltage should pretty much present itself in its entirety up here. There, 360. Sitting here, they're going to drop a wee bit because of a wee bit of current flow in these resistive wires here. The thing that's caught my eye is this out to here. Again, the 365, almost all of it will make it onto this screen. Why have they got it going through the transformer here? So I don't understand what's going on here exactly. Normally you would feed the screen with a nice DC and usually you silence any signal on it with capacitors and stuff like that. But in this case, it's almost as if this is being used as a second plate, like a mini plate or something. I don't know. Okay, so but the issue here is, are any of these windings burned out? That's the real issue. If I pull this tube out, then I open up all these windings, except for here. So if I can find this spot, I could read resistance into the pins up here, actually. Pin 1 and looks like 8, pin 9. So if I can find this point, I can read the resistance between the pinholes where these tubes come from. I can leave these tubes in actually and just read it right off the underside, which I'll have to. Yeah. Well, these tubes. Now I pulled out 2 tubes, one from each side. So I'm going to pull out the rest of the output tubes. All 4 of them out. That'll leave all these wires open. And then we just have to kind of find out where to, it'll be right on these pin numbers. Hey, this is easy. This is pretty easy, I think. Pretty easy, he says. Let's see. Okay, first of all, so if I do find out that the windings have been damaged in one of these output transformers, then that just throws up huge question marks about going forward at all with this machine. So I don't think that's what's going to happen, but we better check. Flip them over. Actually, there's a comment, probably more than one comment on the videos about this exact thing. It's apparently one person's comment suggested that this is a common failure mode for this guy. Short circuits in these tubes are common, these output tubes, this particular type of output tube, and damaging the output transformers occurs. So that's why this is a really important look here. Now, go on over and have a nice look right down on this thing. Output tubes go in here. Your wires, you can spot these little brown wires working their way through it. You can see the windings from here to here going back in the transformer. You can actually see them right here. And again, probably, well, it's going to be the same pins, isn't it? Maybe these two. So I think that's it. I think I just got to look at resistance. Now, wait, there was a third one. There was a wire which was basically going to the high voltage supply. That's it. That's a wire grip sticking out the back of the. See, this one's bent down to hold the wires. This one, they didn't really bend it down. Not that it matters one iota. Well, I can also test right just through the transformer without worrying about the center. So if I did that, you know what? Let's just hook up. Let's just hook up here and stop thinking. Did too much thinking. Let me get better test leads too. So I did something I can work with here. In fact, what I'm going to do, I'm going to put a probe in here, and I'm going to use this shorter clip one. No, I'm not. No, I'm not. You see, I can dynamically change my mind on the fly. On the fly. And talking about insects for a minute, let's just stop for a second. Okay, remember I showed you the Bug Blaster Mark 1. This is my bug killer. Okay, everybody stand back. Let me put this over something black. So it turns out this is really effective. Many spiders and many more black ants have met their demise with the Bug Blaster Mark 1. Even my wife is grabbing this thing, chasing down the ant, and letting them have it. Whack. I haven't designed the Bug Blaster Mark II yet. It's still in the early design phases. So we want this on resistance, and we would want it pretty low. Actually, leave it right where it is. 200 ohms. I wouldn't imagine it's 200. So let's just start with this. These are really dirty. Getting on the right pins. Looks like pin 1 and pin 8. Oh, there's a lot, just a ton of dirt on here. Okay, so we saw the meter jump there. So between these pins, oh, come on, that's greasy. It's like what, 50 ohms was it? About 50 ohms. That sounds okay to me. Holy smokes, I really gotta hack my way through the dirt here. Ooh, different readings, 78, 80. Okay, moving on. Different readings. We didn't really talk about that. I thought this would be a go, no-go kind of thing. Uh-oh. Oh, there it goes. Okay, now if the outboard one measures 50, I think that's proof everything's good. Wow. Tells me something about trying to solder in this thing. So you know, it's probably got thousands of hours of operation on it, warmed up in a restaurant. Guess what? Guess what floats around in a restaurant? Grease. And cigarette smoke by the tons in the old days. 50, 70, 70, 50. Well, I'm pretty reassured that there isn't a problem. I would think if there was any kind of problem, open or short circuit or anything, I would not see a balance through there. I was actually kind of expecting 50, 50, 50, 50 or something like that. So until there's a further indication that there's some problem with these, I think it's a safe assumption. There is nothing wrong with those output transformers. That's a 2 thumbs upper, because that would pretty much end this project. And what's next? So in the background, in the meantime, off camera, here and there, I've been getting ready to go the next step by acquiring or building up the extraneous stuff I need. Oh my gosh. Oh, that is really, really heavy. So one thing I need is a volume control rigged up for this. Still not quite sure what to do about this. So we're going to take a look at the schematic again and study this a little bit. Need to put an input in here. That's easy. That's not really a problem. And speakers. So we have this rather annoying phono speaker jack here. It's annoying. I don't think I have it. You know what? I might actually have something that would fit on that, but nevertheless, I can get at the wires in there, bring them out. I've got 2 big honkin' old, not really big, but big old classic big box speakers. I'm gonna power with this thing when the time comes. And the time can't come until we get a couple of new output tubes also. And what's next here? I don't know, I gotta think for a bit what we should do next. Probably the volume control situation. Let's look into that. Let's get on the schematic here. Here it is right here. Okay. Let's zoom in on this thing here and study it for a bit. This is not your average volume control situation again. So, so this is the socket, and into it goes a plug with these wires coming out of it that go to a dual volume control for a left channel, right channel volume control. R for right, P for poo. So what do we see here? We see basically a potentiometer between here, the slider, and here, and then we got 2 taps. 2 taps that simply go back into the machine. Typically, volume controls are tapped for a bass boost on a low volume. That's one thing that's done anyway. The idea there is under low volume, our ears selectively hear the range where our voice is and begin to not hear anything else. So our hearing is kind of focused down on hearing voices at low level. So to compensate for that, an amplifier like this will boost the bass as you turn the volume down and keep the sound from becoming tinny, I guess. Better known as the loudness control, if it's commonly called the loudness control. So that would explain one of these guys, I would think. It would be the bass thing. Now you take a wild guess that the other one is the treble. That at the same time you're boosting up the bass, you're boosting up the treble. But you know what, I'd have to look at this for a long time, because look, these aren't on the same side of the slider. So one is doing one thing and the other is doing the opposite. Well, that does sound like bass and treble, doesn't it? So maybe this has a more subtle effect than I realize. I used to kind of think that when this passes the point at which there's a tap on the resistive element inside the control, that something kind of dramatic happens. But maybe that's not what happens at all. So I have to imitate this. I have to imitate both of these on my bench. Since I don't have this, I don't have this part. So in terms of the values, there's just nothing on here to give you a hint as to what the value of these things would be. Now this must be. I want to say it one more time. There must be another picture of this somewhere on here. Plug 102, jack 102. Yeah, so this is the plug end of it. Oh, goes right in here. When I kept seeing the J and the P and thinking they aren't related. And then there's this important note here. So if you look, pin number 1 mates with pin number 9. For some reason we don't know, they decided to do that. So we could look at where these are going. Balance control. So these two go off in a decidedly different direction, 1 and 2. That's 1 and 2. So 2, oh, this isn't quite wired the way I would have guessed. So 2 and I would have guessed you could draw a line down the middle here, and one side is a mirror image of the other, and each one is for this. But no, you see the two sliders come in on pin 2 and pin 3. Pin 1, it looks like the grounded side of it, like it's connected to both. So we can assume 1 is the ground, 2 and 3 are the signal coming out of the potentiometer. 4 and 5 are the, let's call it the right hand. 6 and 7 are the left hand. 8 and 9 then are the top. So normally you'd have all the output of the preamp across this control, across this whole resistor, and then you're picking off a piece of it by moving the slider. Okay, after a little bit of searching, found myself some of this wire single conductor stiff stuff, and it's the right diameter to just go in there and stay. Perfect. So what I'm going to do is I'm going to cut 6 lengths of this, some length, I don't know how long yet, probably pretty long in fact. 1, 2, 3, 4, 5, 6 connections, then bring the wires and 1, 2, 3, 4, 5, 6 into here. Probably only need 5. Like I did it differently, I could use 5, but I'm going to do 6. So the two left channel and right channel are absolutely separate, so I don't have a common ground wire, I guess you could call it, coming up here, or neutral wire, or whatever you want to call it. That's what I'm going to work away at. Now I've got my newly set up tip here. Let's just make a quick tip measurement on here and make sure we're in the ballpark. Okay, it should be 250. So that's saying that's getting up towards 250. And my soldering iron controller says 250. There we go. Good. Thought I'd look in my random box of wires, one of my random boxes of random wires, and I found this connector, which matches exactly this. Isn't that something? What a lucky break. You even have a missing pin, and there's a missing receive pin there. This is almost like it's made for it. Let me get it out of here. But it won't go on. And why won't it go on? It has a little grippy wings here. Everything is really. This has got to go, but it doesn't want to go. And why not? So when I look in here, the clever designers of this thing. These are ordinary corners here, but these aren't. They have a piece in them. You can kind of see it there in the camera. If you look at the connector, the space for those pieces exists, but it's here and here. It needs to be here and here. That's right. So this corner is going to receive it. I think you can see it. It goes down. This corner is going to block it because of that thing in there. So what am I going to do? Now, I could grind this down, but this doesn't belong to me. This belongs to me. So I could grind out, chop out, melt out, do something to get rid of these blockers. And then I'm going to have my own speaker plug. Wow! Who would have thought I'd come up with that, eh? I'll go up and explain to my wife why I keep boxes and boxes of junk. Okay, actually I'm not that bad. I'm actually not that bad as it goes for people who do this kind of stuff. Probably you too. I'm actually not that bad at keeping piles of junk. So I think that's the name of the game. Grind this out in here. Zoom. That fits on. And then I've got the speaker wires I need to go to my speakers. Excellent. So I gotta grind this out somewhere. How can I do that? What would be easy? Melting it out of the way would be easy. But that's a little messy. Dremeling it. You know, I could Dremel that. I can Dremel that. I get to use my brand new yard sale Dremel. Okay, since I like showing my yard sale finds, here's one here. Got this a couple weeks ago. Big pile of Dremel stuff here, as if I'm Dremeling every day. No, I'm not that common of a Dremeler. There's the Dremel. Wow, isn't that a big monster? Hardly used, of course. Okay, speed control. I've never used it. Not this one. So we're going to want to get in deep there and grind out the corner. So I need like a like almost like a drill bit. You know, I certainly don't expect there to be a strong need for wearing something like this, but that's exactly the definition of an accident. Gee, never thought that would happen, whatever that is. So let's not take the risk. There we go. Unplugged. So that's really not cutting away the plastic so much as it's melting it away, but it's okay. Now there is some stuff that came out of there. I don't know. Let's see. Did we get all the way? Did I do the right corner? Does it go on? Look at that. It's gonna go. It's gonna go. It's gonna go. Okay, so this is gonna work. Excellent. Okay, next challenge. I got to figure out this plug, which wire's which. And that's great. So let's look at this plug on the schematic. Speaker plug. Now hopefully they show the plug. Yeah, they do. Or do they? Do they? J. Why are they showing 2 here? Actual receptacle, not numbered. Numbers indicated for reference only. Oh, so one is the plug and the other is the receptacle, of course. So this should be running out to speakers. What's it? Whoa, isn't showing. Wow. So where's it going? It's just disappearing. Oh, is there another page on here that shows the actual speaker? So let's see what we got here. We've got a shorting. So when the speakers are not plugged in, 1 and 4 are not connected. And see, 1 goes back to the center tab on this. Wait a minute. Holy jumper. Yeah, there's a good word for it. Really? This is what we're interrupting here? Wow, so the only way this gets connected, and therefore the only way any high voltage is produced anywhere in the set, is to have this plugged in with the jumper between 1 and 4. Let's see, and then 5 is a ground. So 5, so we don't know where these are going, for crying out loud. Arr! Son of a gun. This doesn't look right to me at all. Have I got something totally wrong here? This just doesn't look right at all. It says 16 ohms output. And it's just so surprising that they would mix the high voltage in with the speaker plug like this. I understand what they're doing. They're saying if the speaker plugs are out, no high voltage in the set. Okay, so that's not so difficult. So what I've done is, hey, never use these in your electronic work. But I've used this to put the short between these two in such a way that I can remove it easily. So I don't like using these things. They just, think about it, man. Your house is full of these. Just wires twisted together. But it works. Now, so the ground or the return or the common, whatever word you want to use, is the red one. So that's going to go to both speakers, and then the left and the right are on here. This gigantically long orange wire. I'm going to trim just to make things consistent. There we are. So I'm all set now. I've got the speaker, I've got the volume control not in yet. The input was fairly easy to solve, and then a signal tracer to listen as we work our way through it. So to actually fire this thing up, I've got to get the speakers in here. That's easier said than done. These are fairly big, boxy speakers, but I will do that. Okay, so I'm ready to solder up the speaker wires here. Achieved lunchtime, I think, where we've gotten to. Speakers on the plug. Plug fitting in. Still need to stick in the volume control. Where'd it go? Where'd it go? Here it is. Control. Got to sort that out. Get that sorted out, and we're pretty much ready to power this guy up. Great. Okay, so I think I've got everything ready here. I've got the AC power connected here, double checked, make sure this is the AC 120 volt side. I've got the 6.3 volt side ready to go from my power supply up yonder. I've got a tube complement in here of tubes that have all tested good, so I've got them all the way through, the whole string on this side. The other side is completely empty. Because in fact, there are no good tubes that came with it. So this is really what it boils down to. There's enough tubes to do one side. Well, they were not arranged that way either. I had to move them around. So I got the volume control in. I got it put in like this. This is maybe not wired correctly, but I think it's probably good enough to get us going. And speakers, I have the speakers ready, wired up here. I did a fairly good job so I wouldn't have trouble on the road. About this. So there's no structure inside here. Good. Whew. Okay. But the fact is, it's just too late for me to start trying power to this now. It's just too late in the evening, so I'm going to save it for tomorrow morning. But I think I got everything ready to go. Maybe a quick double check, and then it's power up time. And ooh la wee, we will see. Thanks a lot for watching, and see you on the next video.